Assalamualaikum warahmatullahi wabarakatuh and greetings everyone. My name is Aifni Ghozi and today I will be presenting my final year project entitled Electrical Energy Harvesting from Aloe Barbadensis Miller as an Alternative Potential Renewable Energy. Plant-based energy generation is a renewable energy where electricity harvested from plants. Electricity will be harvested by inserting the electrodes to the living plant. Cation and anion will be attracted to the electrodes. This is called electrochemistry process. Series of experiments will be taken place during the research in order to obtain the optimal output power that could become a potential renewable energy source. Electricity is harvested from plants through the process of electrochemistry. It's a new form of energy source. It is still considered as relatively new research as there are only several research regarding this renewable energy. There are several factors that can affect the output power from the living plant. For example, types of electrode, types of plant, and other factors. Several factors need to be investigated where it may affect the output power through several specific experiments. These factors need to be taken into consideration in order to obtain the optimal output power that could possibly become a potential renewable energy source. The objective is to determine the suitable type of plant for electricity generation. The second one is to evaluate the difference of the output throughout the day. The third one is to analyze the effect of electrodes according to the factors. And the final one is to evaluate the difference of using series and parallel circuit to the output voltage. In order to obtain the maximum output power, these six aspects or factors are being considered. The first one is the type of plant. Four plants will be chosen, which are aloe vera, banana plant, bonsai, and snake plant. The second aspect is the electrode pairing. This electrode pairing will be inserted to these plants through a specific experiment that will be explained later. From the result, the selected electrode pair which produce the highest output will be then tested by increasing the number of electrodes. After that, the next step is to compare the output power of series and parallel circuit with the aid of the plant. For surface area, these electrodes will be cut into three parts and will be tested again in series and parallel circuit. The result will then be compared to the previous result. This shows the experimental setup illustration. The plant that will be discussed is Aloe Barbadensis Millevish, also known as aloe vera. It is a succulent plant. The method of harvesting is both electrodes are embedded into the leaf. Electrodes that are chosen in this experiment are aluminium, zinc, nickel, and copper. These electrodes are selected due to their element properties. These metals are among the active metals with a higher level in the electrochemical series. As you can see, the highest average voltage measured is copper zinc electrode pair, which can harvest 0.99 voltage, which is the highest in the morning compared to 12 p.m. and 3 p.m. The next plant is banana tree. It is a non-succulent plant. The method of harvesting is both electrodes are embedded into the trunk. From here, you can see that copper zinc electrode pair also can produce the highest average voltage, which is 0.89 in the morning also. The third plant is bonsai. It is a succulent plant. The method of harvesting is both electrodes are embedded into the stem. As you can see here, copper zinc pair also produce the highest output voltage, which is 0.86. Lastly, the highest average voltage measured by snake plant is also copper zinc pair, which is 0.64. This can be explained by the level of this metal in the electrochemical series. The higher the level of the metal, the higher the potential energy and vice versa. Therefore, metals that are further apart in the electrochemical series will produce higher potential energy compared to metals that are close to each other. Thus, copper-zinc electrode pair will be used for further research. This result is based on the third factor, which is the effect of electrode distance towards the output voltage. From the table, it showed that as the distance increases, the average voltage and the average current decreases. This result can be explained using electrochemistry theory where electrodes with smaller distance between each other will generate maximum electron transfer. The smaller resistance in the electrolyte causing the current to increase and thus electrons can be transferred more easily. This result is valid since previous research result also contain a similar pattern. The distance in the previous research is from 1 cm to 12 cm, and the result is still similar where both output voltage and the output current decreases as time increases. Next, this is the result based from the fourth factor, which is the effect of electrode pairs increasing towards the average output voltage, current, and power. Only three number of electrode pairs was used due to limited space and the structure of the plant itself. Furthermore, the tip of the plant is not suited for embedding electrodes because of the plant size. This can increase the probability of the electrode to puncture through the plant structure and can cause risk of damage to the plant or worse, die during the research. This increment of the voltage as the number of electrodes increases can be explained according to the Kirchhoff voltage law. The number of electrode pairs will act as the voltage source. Thus, by increasing the electrode pair aside in the series connection, it can contribute to the increment of the output voltage, whereas for the reduction of the current, it is due to the increment of the internal resistance between the electrodes. In other research, as they use 6 electrode pairs, it still shows that the output voltage and the output power increases as the number of electrodes increases, whereas the current decreases as the number of electrodes increases. Next, the maximum power that can be harvested was 482 microwatt by connecting the circuit in series connection. Based on previous research, it shows that the highest voltage output is 6.3 volt in series connection by using 4 plants. This can be achieved since a much higher number of electrodes are being used. Hence, the combination of series connection and parallel connection can be implemented in order to harvest high voltage and high current. This table shows the comparison between the series connection and the parallel connection using the new pair of electrodes. From the series connection between table 8 and table 7, all the output results in table 8 are much higher compared to table 7. Thus, electrodes can be cut into smaller pieces since the surface area of the electrodes does not affect the reactivity of the metal. As a conclusion, based on these factors, this energy has its potential to energize devices with lower power consumption. That is all from me. Thank you.